Welcome to this episode of the AEC Engineering and Technology Podcast, a podcast dedicated to helping engineering professionals find technology that fits their needs. This podcast is the third episode in our 10-episode series called Unveiling Tech Horizons. Throughout the series, we will revolutionize AEC consulting by delving into cutting-edge technology such as AI, BIM, digital twins, PM resourcing tools, and more. In this episode, I'll be speaking with Sean Allen, the Vice President and Global Technical Leader of Digital Technology at WSP. We'll discuss how technology is helping to make buildings more resilient, supporting the transition to net zero, and helping us to better understand and manage climate risks. With that, let's jump into today's episode. Sean, welcome to the show.
Thanks, Nick. It's good to be here today.
And great to have you on here. And to the listeners today, this is a really special episode because, as Sean and I were just talking about earlier, this is really the first episode where we've had a digital practice lead, someone of Sean's caliber on the show. So there's going to be a lot to learn and a lot of great insights. But Sean, why don't we just jump right in here? Could you briefly introduce yourself and tell us a little bit about your background in the AEC industry and kind of about your role here at WSP?
Yeah, sure, Nick. So my background is in math and physics with a master's degree in atmospheric science from McGill University. I actually began my career with MIT Lincoln Laboratory, where I worked on algorithms for reducing aircraft delay during severe convective events. And eventually I became program manager for a major new decision support tool that was used by the airports in the US Northeast. It was a real formative time in my life. I lived in New York during 9/11, had my first two children there. And in 2004, I made a decision to sort of join the consulting world and went to AMEC. And it was there that I led and grew a MetOcean team over a period of about 9 years that was heavily involved in road weather prediction services and MetOcean services around hydrodynamic modeling for coastal and ocean environments. After a period of time, I was asked to chair a global innovation committee at AMEC. And I did that for 2 years. And then that led to a formal digital leadership position for their global consulting business unit just prior to the pandemic. I filled that role for about 3 years, and then Wood decided to sell off that part of the business to WSP. So I joined WSP about a year ago, and I've been working ever since on helping architect their global digital strategy with their chief technology officer.
Which is really an amazing background, Sean, and kind of how you've gotten to this point, and very hot topic in the industry right now, right? Net zero, and the fact that a lot of different individuals are trying to kind of strive towards this goal. But could you talk a little bit about how your efforts at WSP and technology in general are helping to address resilient design and net zero ambitions?
Yeah, for sure. So in the design of buildings, you ultimately want to achieve the lowest amount of embodied carbon possible. You want to maximize the energy efficiency of buildings. You want to design them so that they're resilient to extreme weather events. You want the best user experiences. You want to harness sunlight to get the most out of that building from an energy point of view. But it's difficult to achieve all of those things at once. And so there are complex trade-offs that come into the equation. And that's really where technology comes in. You can use parametric design to create a huge catalog of design options. You can test variations in embodied carbon, energy strategies, et cetera. And then you can visualize those very easily using 3D models, game engines, et cetera. And that sort of naturally leads to another field, which is design optioneering and understanding what options you potentially can take to maximize your success criteria against various trade-offs. And machine learning comes into all of that too. At the end of the day. And so really this is what technology does. It allows you to do many, many simulations against a variety of success outcomes that you're desiring to achieve around carbon, resilience, all of these things to really get to a successful project end. Another better known, maybe more widely known example is really to incorporate climate change projections into design. And that's really where my background as a climate scientist comes in. This might seem straightforward, but there's actually a lot involved in taking a coarse climate grid and then downscaling that to the level of an office building, modeling in the local influences that are there as well, and then building extreme value analysis off the back of that to incorporate design impacts. And there's a lot of uncertainty in those future projections as well that you have to sort of understand and account for. And so that's another area where technology really makes all the difference in the world.
And I'm sure your clients are driving some of this too, right? You'll hear a lot, and I can even speak from my line of work where clients are really interested in, hey, how is, my asset or my structure going to affect climate change and all of those parameters. But could you talk a little bit about how maybe from the client side, some of your guys' clients are leading this innovation charge?
Yeah, well, really what I would say is that innovation is not something that you sit down, design, and toss over to someone for adoption. It's just not the way it works. It sort of starts metaphorically with a scribble on a paper based on a problem that the client has told you about. And then that usually comes to life via computer code, and then it's iteratively tested based on a continuous feedback mechanism with the client over a period of time. You learn from the successes, you learn from the failures, and ultimately the client shapes that innovation every step of the way. And I also personally believe that innovation is not something that should ever be finished. When you build something to address a particular problem, you never stop. You always continue to make it better. You challenge the assumptions all the time because the world around us is changing constantly. It never stops changing. The client's needs are always changing. And, this concept is what I call really rapid prototyping. I was heavily influenced in my thinking in this particular area from working at MIT Lincoln Laboratory, where I had a really good mentor, somebody called James Evans, who was a brilliant scientist at that time. And they built decision support systems live with their clients that were used in the real world under extremely critical conditions. Air traffic controllers are managing planes. And really that way of thinking, it's no different from a client has a problem. We need to address it. You go alongside of them every step of the way. You test and learn, and gradually build it up over time.
And how would you say, there's been a lot of talk about all sorts of these emerging technologies, right, in kind of mainstream media, right? Like large language models like ChatGPT, artificial intelligence, data analytics. But what role are emerging technologies like those helping us become more resilient to a changing climate and aiding essentially, right, this race to net zero?
Yeah, for sure. So the currency of artificial intelligence is really the data we have today, fed by ever increasing number of shrinking sensors. And really what's held us back in the past is the ability to easily organize this data and manage it and make sense of it. And those challenges still exist, but I would say, with generative AI having burst onto the scene this year, I mean, it's been around, but it really got mainstream attention in the last year. It has really driven us forward in our ability to harness and unlock the value of that data. And you just think about something like the collective body of knowledge in documents. Large language models can summarize all that information in seconds and allow us to stop reinventing the wheel. Say we have a project and we're trying to understand community engagement from the past, the local regulatory environment, et cetera. Maybe the project stopped and started. A large language model can go scan all of that data from the past and very, very quickly give you the key nuggets out of it to arrive at key information that can get things moving much more quickly. Another thing is that generative AI is very, very good at building video and picture. It generates imagery from input that you give it. And a lot of our currency in the technology world is in our ability to persuade people through technology to do something, and you do that through the visual. And so generative AI, now you can just say, I'd like a building that looks like this, and this is the kind of traffic flow of people within it, and this is sort of the lighting systems, and we want people to feel really good in that environment, and we can feed it into a model now and quickly sort of illustrate that in seconds, where before you would have had to have a graphic designer do all that work. You thinking about the billions of cameras in the world today, and these can be turned into predictors based on machine vision. And I think we're really only on the cusp of unlocking the value that just comes out of cameras. So ultimately, all of this technology can be used to optimize, decide, design, build, and operate things in a much more efficient and ultimately resilient manner.
Which is exciting because, as I understand it, a lot of this, it coming into the mainstream in the past year or so has really just been due to advances in computational power and really
Yeah,
being more publicly accessible, right?
absolutely. Moore's law, doubling of computing power, and every year, and that's what's happened, and that's what's driving a lot of our ability to do this. Yeah.
And for everyone listening, right, like just think about how much progress we've made in the past year, and then as Sean said, with Moore's law, doubling that each year, and it becomes really exciting to think about what the future holds.
Yeah, just on that, Nick, very quickly, Gartner is estimating that whereas generative AI today is used in only about 10% of text and data processing, in just a year and a half, they're expecting that 70% of all data and text processing will have generative AI attached to it in some way. I mean, that is a massive leap from where we are today.
And speaking of just taking this to a little more of a tangible, let's say program or software, right? Could you talk to us a little bit about Climate View and what you guys have got going on with it?
Yeah, sure. So Climate View is a suite of tools that we have that help clients improve their resilience practices by monitoring future climate impacts, helping communities visualize what that means, and ultimately plan and create mitigation strategies with their local leaders around all of that. So I'll just talk a little bit about some of the tools within the Climate View brand. So we have Adaptive Pathways, and that's an optimization tool that quantifies uncertainty for decision makers, provides alternative scenarios, and produces optimum pathways which are flexible to future change. Aperture is a stakeholder consultation management tool that uses AI to quickly bring out the relevant information that is gathered from the thousands of stakeholders in big projects. Decision View Options uses multi-criterion decision analysis to get decisions more quickly. Flood View is another thing that we've heard a lot about, and that this is a mobile application that is used to visualize 2D floodplain maps, turn those into 3D visualizations of where the water will be against, say, your doorway in a neighborhood. Just by walking around, you can see where the water is lapping based on the local floodplain maps. And then just one more that is part of that portfolio is the Climate Extreme Value Analysis, which is a tool that computes extreme value analysis for variables like precipitation. So what is the worst case 50 or 100-year value of rainfall? And that is typically based on historical information, but then it takes the climate change scenarios that are published every year by the government bodies and adapts that historical information for those climate change scenarios. And then that goes straight into design considerations for a project. So those are just some of the capabilities within the Climate View platform, Nick.
And if you had to say like, hey, like if the questions that like the type of software can answer specifically about climate resilience, like what sorts of questions can the technology provide answers to?
Yeah, so many of those. So, I mean, number one, how can I design for a future where my project will be subjected to extreme weather events? That's a very obvious one. Another one is if my budgets are slashed tomorrow and I still need to achieve my decarbonization objectives, what are my options and what are the trade-offs involved in getting there? How can I get to an investment decision quickly, minimizing the risk and optimizing for maximum results? Another one is how do I leverage data to track what's happening today and then use that to predict failures before they occur in the future? And then I would just say a last one is, and this is a really important one, how do I convince stakeholders in a powerful, compelling way that actions need to be taken? So technology and some of the tools in this platform can help answer all of those questions.
And yeah, that's a great point, Sean, because sometimes stakeholders, they may not quite understand. And let's just use a very basic example everyone in AEC can understand, right? 2D
Right.
drawings, right? They may not understand exactly what's happening, but you may throw an architectural rendering in front of them to get them a better picture, right? For, let's say, a new building, right? But how can data visualization from the climate technology side of things be used to do something similar, right? Increase stakeholder engagement?
Well, really, you said it so well. I could hardly really add to what you said, but it's something I passionately believe in. We live in the age of transformational visual technology. Many of us love to sit down in front of our 4D screens, and the bigger they are, the better. And it provides that experience. And it's really incredible how something that's compelling visually can drive engagement and action. So, augmented and virtual reality and game engines, as another example, are far better at showing risk due to flooding and extreme weather than a 2D PDF. If you don't want action, then just use 2D maps. If you want to spur a community to invest in climate resilience, show them a 3D rendering of water lapping against a second story window homes. That'll get you some action fast. Or in that community park, just to give another example, put a QR code that a phone can scan to bring up an augmented rendering of how the park was designed to avoid future flooding. I mean, that's powerful because that shows tax dollars at work. And so these are the sorts of things that the visualization can really help you achieve.
And it's great because everyone understands, right, the basis of like a photo or a video, and then taking that, to say AR VR, right, just taking what we're already familiar with and then repurposing it to just explain a technical concept.
Absolutely.
So
Absolutely.
what types of projects would you say the software and technology is best suited for? I imagine some are better than others.
Yeah, so really it is two focus areas. One is short-term risk assessment for extreme weather and long-term resiliency plannings. Those are really the two key areas. So if you have assets that are operational, you can use the technology for hyperlocal risk asset management for extreme events. So we have something, just River Signals, one of the projects, and you can set a threshold that you're worried about in a community. It'll automatically message you an alert when a river or stream is expected to crest above a certain level. So that's just one example. And then another one is to prioritize where to place your money for making assets resilient to climate change in the future. I would say that those are the two key things, the near term and the long term, in terms of prioritizing your dollar investments.
And then kind of taking that concept and applying it to, let's say, end users who benefited from the software and technology. Do you have any case studies you can share?
Yeah, I can give you a couple of project examples. So the climate extreme value analysis was used by a client on the East Coast who wanted to understand future rainfall effects in a watershed. And ultimately, this particular use case was insurance, believe it or not. So in this case, climate EVA gave a very clear signature of climate change induced increases in extreme precipitation. And then this was then modeled through a hydrology and a hydraulic model to determine the geospatial extent of the future floodplain associated with that extreme precipitation. And then that was then used as an input into, okay, how does that affect insurance premiums in that particular area? Another example was the use of Decision View Climate Risk that was used by Public Services and Procurement Canada to screen over 50 buildings for vulnerability to climate change impacts across 40 different variables. And in this particular case, and this is increasingly an issue, you've got a portfolio of assets, you have limited amount of money, you want to say, where do I put my money in the first instance against those things that are at the greatest degree of risk? And so building age, materials, elevation, and condition were all accounted for in this particular situation to arrive at a prioritized list that the client got for resilience investment. So those are just two project examples.
Excellent. And as we were talking about earlier, right, Moore's law and just the literally exponential pace that some of this technology is moving, like what are the future trends that you're seeing in climate resilience technology, and how does that all kind of play with what's available today?
Yeah, so a little bit of research here. So Verdantic estimates that the market for portfolio level physical and transition risk analysis will grow at a compound annual growth rate of about 40% over the next 4 years. They also predict that the market for asset level scenario modeling will grow by about 35% over the same period, and that there will be about a 41% growth for business performance climate risk analysis. So, businesses are increasingly being asked by their insurers, what is your risk exposure to climate change? And that is driving a whole catalog of assessments and work from consultants like us to address that kind of a question. From a technology point of view, generative AI, machine learning, optimization technologies, modeling, LiDAR mounted on drones into 3D models from point clouds, all combine these elements into technology really that is going to be in incredible demand in the future. And in particular, I do think that generative AI is going to massively speed up our ability to assimilate large quantities of information needed to assess project vulnerability, simplify stakeholder engagement, et cetera. And then if you combine that with increasing ability to do scenario analysis, like I talked earlier about, with optioneering technologies, the visual technology to convey that information, and then you even take something like modern methods of construction in the building space, which is really modular design and the building information standards that go along with that, there's going to be significant disruption that will propel a lot of advancements in climate resiliency and decarbonization efforts. So I know that's a bit of a long-winded answer, but when you look at the convergence of what is the risk, here are the technologies that you can bring to bear to start to answer some of those questions, and the massive leap just in this year alone in computational technologies, we're going to see big changes in the next 5 years.
And to add a little bit, of additional context, we actually just had, I guess, a few episodes on the podcast, and he had mentioned, take a structural analysis model as an example, right? Like a finite element model that may take half an hour to run through, traditional methods, right? But what artificial intelligence is starting to do is being able to make some assumptions and interpolations, take that modeling down from a matter of, say 30 minutes to a matter of seconds, right? Well, what does that mean? In the case of consultants like WSP, there may be opportunities to just help deliver to clients the same quality or better faster, right? Which is just really amazing, kind of based on what we've seen and what we've talked about today.
It's well said, Nick. I couldn't agree more.
So, Sean, again, thank you so much for joining us today. But as we conclude, what advice would you give to aspiring engineers who are interested in pursuing a career like yours?
Yeah, Nick, that's a great question. This is what I would say. I would say that a good attitude and building relationships are just as necessary as technical skills. If you excel in all three and throw in hard work, you're going to go far. But another element of this is that success is not just how far up the career ladder you climb. It's really about living your values from day to day. And increasingly, we see more and more people who really sort of care about that. How am I making a difference in what I'm doing? And then the last thing I would say is this: never stop learning, because skills become obsolete faster than you would ever think. And so it's really important to have that built-in mindset of what I know today may not be necessary to succeed tomorrow. So those are just a few things that I would offer to aspiring engineers.
Excellent. And Sean, if our listeners want to connect with you, ask you, some more questions, get some more advice, what's the best way for them to reach you?
Happy to have them email me, Nick. My email address is Sean, SHAWN, Allen. So it's Sean.Allen, ALLAN @WSP.com.
Excellent. And for anyone who's listening, didn't have pen and paper to write it down, that'll be included in the show notes. So please, if you'd like to reach out to Sean, feel free. But Sean, again, thank you so much for taking the time today. It's been a pleasure.
Happy to be here. Thank you, Nick.
Till next time, thank you so much. Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you will find a summary of key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all of your engineering and technology endeavors. Thank you.